We are here with Ivan Yonkov, who I met at the Extreme J conference, where he had a great talk uh, titled Reflection is Dead, Long Live Annotation Processing. And that was quite interesting. It was showing, uh, going quite deep into how you can work with annotations. Well, annotations is something that all Java developers probably already know because they have been in Java for quite some time. And there are two ways how these annotations can be turned into some useful features or useful functionality. So basically, we don't have to write some boilerplate code. We can concentrate on what's important, what's the business logic, and we just put some annotations on that code. And by some magic, some common functionality that we need is added to our code. And the two approaches that can be taken to do that are the first one is using reflection, which happens at runtime. And the other one, which basically Ivan prefers, is using annotation processing, which allows us to do it in the compile time before the application is started. So we save a lot of time, maybe also some other resources. So I liked your talk in that it was really like pure. You tried to avoid unnecessary dependencies. You didn't do any special framework. You just used pure Java and tools like Java C to compile the code. However, from the perspective of a typical Java programmer, we usually use some kind of a framework or maybe some libraries. And actually, maybe also to give some examples, you also mentioned Spring Framework there as an
Yeah,
example of something that uses the first method that uses reflection, and that's causing the startup time of Spring or Spring Boot applications to be maybe longer than necessary because that processing of annotations and preparing all the code to handle them takes some time. And yeah, I can maybe I was thinking about it a little bit, and I also can say about tell some other examples. For example, uh, many Java programmers use the Lombok framework, which also adds some functionality. And this one is already an annotation processor, so it's done at the compile time. Another example would be maybe Mapstruct for mapping beans. And I actually remember another tool that was called Dozer, and that's the other option because Dozer used reflection and did its work all in runtime, and that's why it was a little bit slower than Mapstruct. And now, if we talk about Spring, it's of course it's a very popular framework, but we have some new frameworks that are a little bit younger, like Micronaut or Quarkus, and it seems that they use exactly this. They jumped into this trend that they try to avoid doing dynamic things at runtime, and they prefer to do annotation processing at the compile time so that everything is already ready and when you start the application, it can start doing what it needs immediately. So maybe my question would be, do you actually use a framework, or do you do everything with pure Java?
Yes, so my talk was stripped out from frameworks so people can easily understand what happens behind the scenes. Otherwise, I would be hiding behind some framework and saying that the only way to do it is the framework itself, which is not, of course. So I wanted just to deliver the message how people can leverage this agnostic from the framework. But yeah, we do use. Oh, I'm representing a company that's a service consulting company, and we have many clients and partners, and they prefer different kind of frameworks or infrastructure that we should comply with. So yes, mostly our clients prefer Spring, which has this burden mm, of the slow runtime. And that's a lot of other runtime penalties if you want to introduce more dynamism. Like if you define some aspects, they're also in the runtime as well, which is kind of fine. But still, it would be good if we could have if we could have the chance to add some other functionalities to the methods. If it was in the compile time or some way to manipulate the bytecode beforehand and then execute it. But yes, we use mostly Spring in most of our clients and Quarkus in others. And I would say have little to none experience with Micronaut, so cannot say anything there. And using annotation processing, it's framework agnostic at all. Either it's Spring or Quarkus or something else. You can do your compilation phase, bundle it into a Spring project. In that sense, we also use some libraries to process the annotations and to construct the new code. Because in the talk itself, it was a very simple example where you can construct it with a simple string builder. But in reality, you have more complex code that you want to produce, and you want to maintain packages and symbols across different classes with their imports and stuff. So it's harder to maintain it manually. And there were already some decent solutions on the market. We've been using this Java Poet one, for instance, which actually stopped to be maintained by the original author. It was transferred to someone else, but we still use the old version, which is called still Java Poet from, I think it was Square that were developing it before. Mm, and
Okay.
yeah, I like a lot the Quarkus solution because we have several clients that are struggling with this auto scaling when they need to scale, and they have already the jar that has to start, but it starts for 20 seconds. So you start scaling, but you have very big cold start. And for instance, Quarkus was giving a lot of advantage to these customers that were leveraging it, and Spring, on the other hand, was a bad solution for this kind of auto scaling.
Okay, so yes. So to get back to what you showed in your talk, yes, your example was quite simple, and you also mentioned that for more complex applications, you would probably use a Java Poet or some other library, so that you can generate larger code blocks, and it would stay maintainable. Yeah, but again, from the perspective of a typical Java programmer, I would, if I can, I would definitely try to avoid having to write some generator and use some new library. And you even mentioned bytecode manipulation that could come into play at some cases. So, can you tell me what would be the trigger? What would be the point where you would say, okay, some some typical framework is not enough for what I need to do, and it maybe I should think about using annotations directly and maybe generate some code using some annotation processor.
Yeah, so the frameworks, first of all, do not define the whole code base that you're creating. Sometimes you want to have a code base that is shared across different, let's say, output adapters. Um, you can have a lot of code base that is framework agnostic, and some of them is exposed through some Spring application, some others from some other application. So in that case, your core application is framework agnostic and you cannot leverage any of these frameworks at runtime. And also, you would have the runtime penalty if you use, let's say, the aspect-oriented programming
Mhm.
of Spring. So there are a lot of examples. Let me get back to your initial mm, when you initially said that Wombok is one example of annotation processing tool, it is with the caveat that it manipulates the real classes.
Yes,
So
exactly,
yeah.
and that's why I don't like it so much actually, but it's widely used.
Yeah, annotation processing is not giving you this possibility. You cannot use the output writer inside the annotation processor to manipulate the existing class. It would say that this class is already there and you cannot change it. So what were what were Lombok doing prior Java 17 is that they were using this private Java compiler classes to change the original classes. And after Java 17, I'm not sure. I think they tricked the Java compiler that they are in the same package of the Java compiler. I think they have predefined their own classes inside sun.jdk or com.org or something like that. So
Mhm.
they're tweaking it once again.
Yeah,
Uh,
I noticed that when upgrading to Java 21, I had some problems with Lombok and I had to upgrade.
Yes, they did some nasty hack to overcome these limitations that were put inside these classes, and still they are leveraged at some point. What we do in such cases where we want to manipulate the same classes, because uh, if you only generate new classes and you don't have some common interface that is kind of injected somewhere, you cannot use it in your code base, right? You need first to run the annotation processor to scan annotations to create the new classes, and then you can type your code. And this is pretty inconvenient. Sometimes you want to do it in in existing classes. And in such cases, this is one of the use cases, not the only one, but one of the use cases where we use bytecode manipulation. So you manipulate some things. Sometimes it's some small change. This is the simplest thing that I can say. Sometimes what we do, you have the original class, then you generate a class that has the same name as the original class, but with the the end letter is just changed to underscore. So you have the same functionality from the original class. You have the enhanced functionality from the annotation processor, but it's in a different class. And what we do is with simple bytecode manipulation to change the class name.
Uh-huh.
Because it's in the class table, the class file format says the class name resides here. So we just change it with bytecode manipulation and rename the file after that with file system operation. And we had this in a lot of cases where we want to enhance a class that is already there. Instead of doing very nasty hacks, we just generate new one, rename it to bytecode manipulation, and
Mhm.
leave it the only one that is there. So in this case, no Spring or whatever can help me at that point.
Mhm, mhm. So basically, you say you wanted to have something that is framework agnostic and maybe do something that's like, I don't know, combining multiple things.
Yeah, yeah. If I want to simplify it, because it's harder to bring the whole picture here from what we are doing. for our clients and some of the things I cannot say, of course.
Hmm.
But if I have to simplify it, if we took the example from the session where we have a simple factory that was switch casing through different strings and producing new objects. Let's imagine that you already have some factory class that has 10 cases in switch and you want to add 10 new cases. So what you do in real annotation processing scenario is taking the code of this class, adding your new code, creating new class, deleting the old class file, and the new class just rename it with bytecode manipulation and file system operation. So you actually trick it and you receive a new factory with 10 new cases with inside the same class name. And
Hmm.
the code is there. If you control click it or command click it or whatever you use, you see the 20 cases instead of the 10 cases.
Hmm. Okay. Okay. Yeah, these things that are like typically where you have some cross-cutting functionality, or where would you would maybe like to use aspect-oriented programming. I focus a lot on integrations and APIs, and I see that this is quite a common use case, that for APIs you need some common functionality. Like for example, you actually also mentioned it in your talk that can be authentication, and you can have different ways of authentication, or it can be, for example, logging, auditing, or it can be also some other manipulation that you want to do for all your endpoints, basically. So, do you think that that could be also something that somebody who integrates services, that they should consider also using notation processing in that area?
Well, in that area, if you just want to enhance it, like adding logging or like in our case, in different service methods, we need to inform different regulators. And this kind of logic can be composed whether you're on jurisdiction 1 or jurisdiction 2, whether some configuration properties are there or not, and other stuff. Well, at this point, maybe it's better to use some aspect-oriented programming, like if you're in Spring context, Spring AOP. So you just use these cross-cutting concerns to capture all the methods that are in some service or some package or returning something, and just add whatever is needed. This works fine. If these services are inside a framework, you can still have the services outside your framework, like in a different jar. And if you expose them to Spring or to Quarkus, you can just add the relevant aspect-oriented thing inside your framework. So it's fine. What does not work that good for us is if you want to enhance functionality on much lower level. For instance, if you want to capture all, let's say, input stream read operations, it's kind of hard or almost not possible to do it with the normal Spring aspects, because they capture things that are managed by Spring, and when it comes outside what is managed by Spring, it starts to get harder to not be registered, and then you need to start making hacks and hacks and hacks. So at this point, probably framework-based aspect-oriented programming is not the best choice,
So, so
according to
you
me.
say input stream, or sorry.
Yeah, for instance, some JDK class like the input stream, you want every
Mhm.
operation that is consuming an input stream to to be enhanced, for instance, to be walked or to be sent to auditors or something like
Mhm.
that. Then you need to capture the read method of every input stream inheritor, like the file input stream, the URL, HTTP connection, and whatever or you can have. Most of them are classes inside JDK and not
Mhm.
beans in spring.
Okay, okay. But anyway, even if you use aspect-oriented programming, then of course you need to accept that increased that overhead that
Yes,
it brings in runtime.
yes,
So
yes.
so in case you are very uh, sensitive on resource consumption and startup time, maybe that could be also uh, uh, case when you would consider optimizing using some other solution and not using the standard AOP.
Yeah, but what kind of choices do you have when you want to enhance a JDK class?
Mm-hmm.
Um, this is this can be a really open discussion for whoever is
Mm-hmm.
um, whoever is listening here, because it puts the interesting point of how to efficiently enhance classes like the inheritors of input stream.
Mm-hmm.
One way is to generate a new one to annotation processing, of course, and be used everywhere else, but that makes it very hard for the whole application to not use, let's say, the URL connection and use your inheritor that is enhanced. So probably this is a solution. Never tried it, honestly.
Mm-hmm. Mm-hmm. So okay, that's all. Of course, that could be interesting, like a very low level place where you would want to have some enhancement. Uh, I don't know why I would need it, but yeah, there may be, like you said, maybe there might be some special auditing requirements, right?
Yeah, yeah. Whatever comes and goes out of the network, you need to audit it. This is a case that
Uh-huh.
is happening.
Uh-huh.
So we need to intercept everything on socket binding and
Mm-hmm.
receiving and
Mm-hmm.
sending levels.
Okay. Okay. So I think we've uh, explained some points, and hopefully it will be helpful to people who watched your talk or generally who are interested in Java in a more advanced way. So thank you for answering my questions, and yeah, good luck in your future sharing of knowledge.
Yeah, thank you very much. I hope it was useful for our listeners as well. Yeah.